Hello students, welcome back. How are you all? Today we are going to solve this theorem that we have left in our previous session. I've told you we'll cover this in the next lecture. So the theorem is if E, F, G and H are respectively the midpoints of these sides of a parallelogram which is given ABCD. ABCD is a parallelogram which is given and we are having E, F, G, H as the midpoint of this side AB. So this is E. And this is F, this is G, and the last one is here, H. Okay, so when I'll meet these 4 points, I'll be having an area EFGH. Now, what I have to prove? I have to prove that this area EFGH is nothing but half the area of ABCD. Okay, so first we'll prove. To prove this area equals to half ABCD, first we will be proving that this is a parallelogram basically. EFGH is a parallelogram. Okay, then what we'll do as a construction? As a construction, we'll be meeting this H to F. Okay, again, we will meet this H to F for the construction. Okay, then we'll be having these two parallels AB and HF. And we are having this ABFH parallelogram. On the same base, we are having this triangle EFH, triangle, parallelogram on the same base. Okay, so we'll be using the area theorem of them. Similarly, we'll be applying them for HF and DC, and in that case, we'll be having this HFCD as a parallelogram and this F, H and G as our triangle. Okay, so let's have a look where it goes. Right. So first come first, we have to prove first that this is a what parallelogram. Right. Okay. So proof construction. You'll be having this construction that meet H to F. Now H and F. H and F are midpoints of AD and BC. Also, AD is parallel to BC and AB is parallel to DC. We are having these two lines parallel, so parallel and equal. And we are having these two lines parallel, so parallel and equal. That means the midpoint of this and midpoint of this will create what? This line AD in two equal halves. Similarly, here F will part this line BC in two equal halves, that is BF and FC. Okay, so this line segment AH is equals to this line segment BF, right? Okay. So this implies that this line segment AH is equals to BF. Now AH is parallel. AH is what? AH is equals to BF. Also, part of parallel lines are also parallel to each other. Also, AH is parallel to BF. Now, we are having these two parallels and this one AB and HF are also parallel. Okay. AB is parallel to HF. Right. So, clearly, this ABFH, this implies that AB FH is what? A parallelogram. Okay. So, this ABHF is what? A parallelogram. Right. First thing. If this is a parallelogram, ABHF or FH and this is a parallelogram and triangle, this triangle HEF are between the same parallels AB and HF also having same base what? HF. Now, if we are having the same base in between the same parallels, then what is the relation between the area of a parallelogram and the area of the triangle? That the area of the triangle is just half of the area of the parallelogram. Okay, we'll use that here. Okay, this implies that area ABFH is equals to twice, okay, of area, the area of triangle HEF. This is the second thing we are having. This is the second thing, and similarly we can see here in this particular parallelogram HFCD and HFG, the triangle. We can apply the same thing here because here AB is parallel to HF. Similarly, we can say that HF is parallel to DC and this HFCD is a parallelogram. Okay. Similarly, HFCD is parallelogram and this HFDC is parallelogram and HF is parallel to DC. Okay, implies that HFG, this triangle HFG and parallelogram, which is the parallelogram HFCD are having again what? Same base and between same parallels, right? Okay. So we are having the second point and that will be our third, which will be the conclusion. I'll be letting you know. Just we'll be rubbing this part and I'm rubbing it till here. The second equation of ours. Noted? Okay, then the second conclusion was this: if these are two figures, one of it is a parallelogram, second of it is a triangle, that again means that we can apply the theorem, area theorem, and that is, this implies that area HFCD is equals to twice area of our triangle HGF. Okay, this is second, no, not second, third. This is third. By second and third, by adding second and third, what we will get? Let's see. Area HFCD plus area, what was the area here? ABFH in this second equation. Okay, will be equals to twice of, now first this area HGF, okay, and then second from this equation area HEF. Okay, now solve this again. What we are having? EFCD. So, E, F, C and D. Not area EFCD but HFCD. Okay, so HFCD. So, these are the 4 points. So, first we are having this area and plus in addition we are having this ABFH. ABFH. So, we are having basically this area. So, the complete area is ABCD. So, I can write here that that will be area ABCD will be equals to twice of what? Area, first HGF, so H, G and F, this one, this area, and the second area HEF, HEF, this area. So this complete area will be what? The area EFGH. Okay. Area EFGH. That means area ABCD okay is half equals to area EFGH. I have just transposed this to here. Okay, and this what we were seeking for to prove, right? So hence prove. This is your solution for this question. Okay, understood? I clear it out? Okay, move with the next question. In figure P is a point in the interior of a parallelogram. We are having a point P here in the interior. Okay, and we have to prove that this area APB plus area PCD equals to half area ABCD, and also we have to prove that the area APD is plus area PBC equals to area APB plus area, again corrected here, this is nothing but the area PCD. Okay, understood this thing? Right. So we have to prove these two things. Now to solve this, what we are going to do, we are given only with the point P here. Okay, so we have to construct something in order to solve this. So our construction is basically, we are going to draw a line which is parallel to DC, and because DC is parallel to AB, this line is going to be parallel also to AB. So that is AB is parallel to, if I'll name it as E and F, that will be AB is parallel to EF parallel to DC. Okay. Okay. Then we'll be proving these things. Okay. So first come first. For the first, our proof is, so area APB is equals to plus area PCD. This triangle, we are talking about this triangle and this triangle, these two triangles first and this triangle second, okay, equals to half area ABCD. Okay, luckily we are having this theorem, area theorem, that the area of parallelogram on the same base, if I am having a area of a triangle, then the area of the triangle will be the half of the area of parallelogram, and we are again using the same theorem here. Okay, okay, so use that. Now, before proof, let us write construction here. Draw EF parallel to AB parallel to DC, passing through point P. Okay, right. Now, ABEF is parallelogram, as AE is parallel to BF, and why AE is parallel to BF? Because part of parallel lines are also parallel. Parts of parallel lines are also parallel to each other. This is one. Then this is here, that this AB is parallel to EF, and what, this AB is parallel to EF. Why? Because of our construction, we have construct that. Okay. So, parallelogram ABEF and triangle ABP are on same parallels and between the same are on the same base and between the same parallels. Okay, so by our theorem we can now say that area triangle ABP is equals to half area ABFE. The area of this triangle will be half of this area of this parallelogram. Okay, so this is one. Similarly, if we talk about EF and DC, so EF and DC are what? Parallel to each other. Similarly, ED and FC are parallel to each other. That means this EFCD is a parallelogram, and again this BPC is what? A triangle. These are between the same parallels and the same base DC. That means the area theorem is also applicable here. Okay, so this is one. Similarly, area triangle is DPC is equals to half area EFCD. Okay, so this is the second one. Right? Now, what we'll do? We'll just add these two and we'll get the appropriate answer. Okay. So, by 1 plus 2, what will be getting? Area ABP plus area, which area? DPC is equals to half of area. Now, this area ABFE plus area, which area? This is area ABFE, okay. So, correct this here. Area first ABFE and the second one area EFCD. Okay, and then we'll combine them. What we'll be having? We'll be having area ABP, okay, plus area DPC, plus area DPC. These two areas are what? Area, half, we can take half common, okay. So, area ABP plus area. Now, area DPC is this, and again area PCD is this, okay. So, we can write PCD here is equals to half of what area? This plus this. Now, look at this. This area ABFE and this area EFCD. These two areas are making this area ABCD. So, basically this is area ABCD. Okay. So, this is what we have to prove right here. So, hence prove the first part is here, over. Okay, so we have proven the first part, right? Okay, what about the next one? Let's have a look. The construction will be remaining the same. The second part too, the construction will be like that. We should understand first what it is trying to say, that area APD, this area, plus area PBC, this area, equals to area APB plus PCD. These two areas, summation of these two area is equals to summation of these two area, according to this. Okay, how will prove that? Okay, we'll be taking help of this already proven thing, and we will conclude with this one, second part. So second, area APB plus area PCD is equals to half area ABCD. Clear? Now, if I'll talk about this complete area ABCD, this is first. So, area ABCD is nothing but this area APB plus area PCD, okay, these two, right, okay, plus this area, what we have to prove, APB, and this is APB, okay, APB, and plus area PCD, area, right, area here, okay, area PCB, yes, area PCB. So basically we are having this area PBC, okay, area APB, this area APB, okay, we have written it twice. So we have taken area APB, then area PCD, these two triangles. Then we have to take this triangle ABP, okay, APB. We have taken this APB, we have taken this PCD, okay, now this triangle which is APD, okay, area APD plus area, this area PBC, which is this area, okay, right. Now, we can write this area APB plus area PCD equals to half area ABCD, okay. So, basically APB is this plus PCD, this. So, we can write area ABCD is equals to, this complete is half area ABCD plus area APD plus area PBC, right? Okay. Then just bring this half ABCD here. Area ABCD minus half area ABCD will be going to be half ABCD, okay. So, half area ABCD is equals to area APD plus area PBC, okay. Now, name it equation second, and the very first that we have proved is first. By comparing first and second, by comparing 1 and 2. Now, when we are comparing these two, what will be saying that this is half area ABCD. So, half area ABCD and half area ABCD. These two are equal. So, basically this area APB plus area PCD, this is area APB plus area PCD is equals to what? Area APD plus area PBC plus area PBC. So, again hence proved. Okay, any confusion in this question? No? Okay, let's move to the next question. In figure PQRS and ABRS, okay, these are two parallelograms which are given. Again, the parallelograms are first ABRS. So, ABRS, this is a parallelogram, okay students. And the second parallelogram which is given is ABRS. ABRS. Okay, so PQRS. PQRS. This is the first parallelogram, that is the second parallelogram. Now we have taken a point X on the side BR. Okay, now show that first area PQRS equals to area ABRS. Now we have to prove that these two parallelograms are having what? Same areas. Okay. Proof. PQRS is a parallelogram. So what? This PQ is parallel to SR. Also, this PQ is parallel to SR. Also, this AB is parallel to SR. And that's why, because this ABRS is a parallelogram. Now, this part is parallel to this part and this part is parallel to this part. That means AB is parallel to SR. This implies that AB is parallel to SR. Okay. Now, parallelograms PQRS and parallelogram ABRS are on the same base SR. Okay, and between the same parallels and between the same parallels, which are AB and SR. We are having the common base SR and also the between same parallels AB and SR. That means that we are going to have the areas of these two parallelograms equal, because if you are having the same base and the parallelograms on the between the same parallels, then the area of the parallelograms are going to be equal. Okay. This implies that area PQRS is equals to area ABRS. Prove. So, this is the first part we have proved. For the second part, area AXS, okay, is equals to half area PQRS, half area PQRS. This is the first part, so we are going to write it as equation 1. Now, with the second thing, what we'll do, we will be having this parallel line, set of parallel lines AS and SR. Let me use different color. So we are having these parallels AS, okay, and BR. These are parallel to each other. Again, this is ABRS is a parallelogram, and this AXS is a triangle between the same parallels BR and AS and having the same base AS. Okay, so we are just going to use again the area theorem here. Triangle AXS and parallelogram ABRS are between same parallels. Which are the parallels? AS and BR and same base, which is the same base AS. Correct? Okay. This implies that area ABRS is equals to half area AXS. Not half, but is twice. Okay, it's twice area axis. AXS area is half of the area PQRS, or you can say the twice area AXS is equals to area ABRS. Okay, so this is second. Now, but area ABRS equals to area PQRS. Why? We can say it by the first equation. So, just putting the value here, putting value in equation 2 implies that what I am going to do, I am just going to replace the value of ABRS with the PQRS. Okay. So, area PQRS is equals to half area AXS, or you can write that area AXS is equals to half area PQRS. Okay. So, this is what we have to prove. Okay. So, note it. Next, a farmer was having a field in the form of a parallelogram PQRS. What was the farmer having? A form of shaped parallelogram that is mentioned here as a PQRS, and she took any point A on RS. So, let us take any point A on RS. So, let us have this point on RS, okay, point A. Okay, and join it to point P and Q. Now, this point has been joined to P and Q. Now, what are the, in how many parts the field is divided? How many parts did you see that the field is divided? You can clearly say that, ma'am, these are 3 parts. 1 is here, 2 is here, 3 is here. So, we can just write the answer first question. The field is divided into 3 parts. You can write the parts also. Area PQA, area SPA, and area AQR. These are the 3 areas. Okay. In how many parts in the field divided? What are the shapes of the 3 parts? Okay. Look at here. This is triangle. This is clearly a triangle. This is also clearly a triangle. The shape of all the fields, or may you say parts, are triangle. Okay, now in how many parts? Okay, what are the shapes of these parts? We have done that. The farmer wants to show wheat and pulses in equal portion of the field separately. How should she do it? Now, what the farmer wants, that she should have some sow some wheat and pulses. Wheat and pulses, there are two categories. Okay, in equal portion the field separately. How should she do it? By just only looking at it, we have just used enough area theorem. Then we can just now tell that we are having this SR is parallel to this PQ. Okay, and we are having this point here that makes this triangle and this parallelogram between the same parallels and on the same base PQ. Okay, first thing. Now, the area of this triangle will be half of the area of this parallelogram. So, basically this is the half and the rest is also half. So, if we will be using this wheat, if we sowing this wheat here in the triangle area, then the left area, the area number 1 and area number 2 will be getting pulses. This is simple. Okay, so we are just writing the more clear way. Okay, so what was that? We were having here a point A. Okay, that was our triangle which have been formed. Okay, now solution. Triangle PQA and parallelogram PQRS are between the same base, same parallel, PQ and SR also having same base, PQ. This implies that area PQRS is equals to twice of area PQA. Okay, now also we can say that area PQRS is what? Area PQA plus this area PQA plus area PSA plus area QRA, which is equals to what? To area PQA. So here we are having 2 area PQA, here we are having area PQA. So when we will transpose that that area PQA, this and this will be changing to area PQA. Okay, so here that will be area PSA plus area QRA is equals to area PQA. Okay, and this is of our use. What we'll write now? Farmer can sow wheat in area PQA and pulses in area PSA plus area QRA. Okay, so basically this This will be the area of wheat grown, and these two area will be of pulses. Okay. Now these two area is equal to this single area. Okay. This is how this question is gonna be solved. Now clear? Okay. Talking about next, triangle on the same base and between the same parallels. So we are going to solve this, we are going to understand this triangle on this triangle on the same base and between the same parallels. So we have talked about the parallelograms. Okay, we have talked about a parallelogram and a triangle also, that the what is the relation between these two. So similarly, in this we will be knowing that what is happening when we are having the base as the same and the triangles are between the same parallels, same base or equal base. In both the cases, what is the relation between the two triangles formed? Okay, so we will meet with this topic in our next lecture. This is all for today. Thank you.